Hello, in this video, we'll be covering the various ways of purifying solutions, as well as measuring quantities of volume.
In chemistry, measurements are a crucial part of this subject, as experiments and their results play a major role in the credibility of these scientific theories. There are many quantifiable features that can be measured in units. Below is a list of the common ones. Filtration, the process in which solid particles in a fluid are removed by the use of a filter medium, here filter paper, that permits the fluid to pass through but retains the solid particles. Either the separated filtrate or the solute removed from the fluid may be the desired product. It is a relatively simple process to carry out. The equipment needed are listed in the diagram below. Fractional distillation is a method of separation for a mixture of miscible liquids with different boiling points. The basic principle of this type of distillation is that different liquids boil and evaporate at different temperatures. So when the mixture is heated, the substance with the lowest boiling point starts to boil first and convert into vapors. Then the liquid with the next closest boiling point starts to boil, and so on until all the liquids are separated and collected on the other end. The condenser helps cool the vapors back into liquid form so they can be collected safely. There are glass beads, as you can see in the diagram, in the fractionating column. The glass beads present in the fractionating column provide a large surface area for the hot vapors to cool and condense rapidly, aiding the condenser in bringing the vapors back into liquid form in time. Fractional distillation has many real-world applications. It is used to separate the fractions of petroleum, crude oil into kerosene, petrol, diesel, paraffin, etc. It is also used to separate oxygen and nitrogen from liquefied air. Nitrogen is then used for keeping chips fresh, and oxygen is then used in diving tanks or in hospitals. It is also used to separate ethanol from a mixture of ethanol and water. Paper chromatography is used to separate the components of a mixture, for example, the dyes in ink. It can also be used to identify additives in food, such as flavorings and colorings. The steps for this process can be inferred from the diagram. In special scenarios, to separate amino acids or simple sugars, we have to use a locating agent, which is different depending on the substance, to make the spots of the individual components visible.
Crystallization is used to separate a dissolved solid from a solution, for example, dissolved copper sulfate from water. To remember the process of crystallization, think of the acronym CCFD: crystallize, cool, filter, and dry. The solution, consisting of a dissolved solid, is heated in a basin until the crystallization point of the solution is reached. To see whether the solution has reached its crystallization point, a stirring rod can be dipped into the solution. If crystals of the solid are formed, the crystallization point has been reached. The solution is then left to cool as crystals of the solute are forming at the bottom of the basin. The crystals are then filtered and dried. In simple distillation, we can separate the solute and solvent without having to sacrifice evaporating the solvent like crystallization. However, note that distillation can only be used if the solute and solvent have very different boiling points. In the example of separating salt from water, the salt water is heated and pure water evaporates, producing a vapor which rises through the neck flask. The vapor passes through the condenser where it cools and condenses, turning into pure liquid H2O, which is collected in a beaker. After all the water is evaporated from the solution, only the solid solute, which is in this case the salt, will be left behind. In chemistry, we have to take accurate measurements of volume, temperature, mass, etc. The accuracy of these measurements are determined by the apparatus used. In the table presented, we have different types of apparatus used to measure volume, each varying in their accuracies. Before we explain each of the apparatus, it's important to note that volume is often measured in dm cubed. 1 dm cubed is equal to 1000 centimeters cubed. The purpose for each of these apparatus vary. A burette is used as an accurate way of measuring any volume of liquid up to 50 centimeters cubed. A pipette is used to measure fixed amounts of volume. For example, a pipette can measure only 25 centimeters cubed or 50 centimeters cubed, no in between. A measuring cylinder is used as a way of measuring large volumes of liquid when accuracy is not as important. A burette usually comes in the size of 50 centimeters cubed, while a pipette comes in a fixed size of 25 centimeters cubed or 50 centimeters cubed. A measuring cylinder ranges anywhere from 10 centimeters cubed to 1000 centimeters cubed. The scale divisions on each of this apparatus also vary. A burette has scale divisions every 0.1 centimeters cubed, making it very accurate. A pipette has no scale divisions because it only measures a fixed amount of volume. A measuring cylinder usually has scale divisions every 2 centimeters cubed, making it not as accurate as a burette. Before we end the video, here are some important definitions for your own reference. A solution consists of a solid dissolved in a liquid. A solute is the solid that is dissolved in the solution. A solvent is the liquid that dissolves the solid. An unsaturated solution is a solution that contains less than the maximum amount of solid that is capable of being dissolved. This means that if any more solute was added to an unsaturated solution, the solute would dissolve in the solution.
Thank you all for watching, and I hope you learned something new. See you soon.